Okay, my name is Bridget Johnson. I teach 7th grade math and middle and high school robotics at Lexington, Oklahoma. And my lesson plan is actually on the engineering design process. And so initially teaching that to kids, it's a problem I've had with my robotics students, that they don't like to iterate things that they build. They want to stick with the same thing, whether it works or not. And so this was just a little project I put together that might help encourage that. And then I have some math extensions at the end, which I do have in the lesson plan geared towards 7th grade standards, but you could certainly alter those for other grade levels. So I will start. Does anyone in the room have a boat? What kind of boat do you have? Like a little rowboat?
We have a trolling motor.
Oh, okay, a trolling motor on it. So what would you say its purpose is?
So we can catch all the fish.
Okay, so you can catch all the fish. Nobody else has a boat. You have a kayak. What's the purpose of your kayak?
Paddle around in the ponds.
Paddle around in the ponds, little recreation and exercise. Okay, so there are different kinds of boats. We might make it a little easier and say boats in general. Can anyone think of a specific type of boat and what the purpose of that boat might be? Yes, Corinne? Good answer, Corinne. What is an aircraft carrier built for?
Putting warheads on foreheads.
Putting warheads on foreheads. Yes, spoken like a Navy woman. But it is built to land planes even on, and store equipment, transport people. Anyone else have any ideas? Yes, Karen?
Tugboats.
Tugboats. What's a tugboat for?
To guide the aircraft carrier into port.
Yep, because the aircraft carrier's really, really big.
Oil tankers.
Oil tanker. What's that for? Pretty obvious by the name. Import, export oil. So it needs to be built with big tanks and the capacity to be able to hold and transport those. So all boats have a reason. I always say bass boats are made to have the biggest motors and get to the fish first, right? So boats have all different purposes, and what we're going to do is design a boat and build it for the purpose of speed. And we are going to use the engineering design process to do this. I do have a video I won't be showing here, but I have a link in the lesson plan that equates the engineering design process to planning a taco party that actually should be pretty engaging for the kids. So I am using the steps in that video, and we'll go from there. So first, we need to define our problem. Anyone have any idea what our problem is?
Make a fast boat.
Make a fast boat. Very good answer. Clumsy me. So the second step is going to be to identify our constraints. So over here I have what I've put in just a little kit for the teams. I do have the kids teamed in groups of 3, and I like to keep kids standing in my room as much as possible because I find that they think better, they engage better when they are standing. So I try to keep a pretty active classroom. Some of this material may not be used, some of it might. I will give that instruction to the kids and say, you don't have to use everything in your kit. You can trade items. You could get an additional item from the teacher, or with teacher permission, you could bring something from home. I don't repeat that information because I would like for the kids to maybe try to use it all. And you know, they'll come up with some really funny designs or interesting designs. So I have a bubble mailer, not very ecological, but it is good material to insulate your battery pack that comes with the motor. You need to keep this dry. We're racing the boats in water, and it's a good way to keep that dry. A sheet of paper, a straw, a balloon, and I found some cute little smiley face balloons, couple of rubber bands. I did different sizes. This is the kit that I got, the electronics kit, which has a motor. It is not a submersible motor, so they need to keep it somewhat dry, but they need to keep the battery pack completely dry. There is also a switch, and the kids will need to wire that themselves, and I would suggest doing some shrink protection on that, which you would need a heat source for, either a heat gun, a blow dryer on a high setting, or if you're really brave, a lighter, but that might be frowned upon by your school. So the kids should have some idea of circuitry, or maybe you want to use this to do a separate lesson on setting up the circuit to create these on the switch. Then I also gave them some tools with which to carve a boat out of a foam block. Unfortunately, I forgot my foam block today. And some wire strippers, because they probably will need to strip the plastic off of some of these attachments, and a roll of duct tape. So those were the implements I chose, but you could choose different items for your kit, and that's where we go over the kit. And then I would talk about what are our constraints in building the boat. Anyone have any idea what our constraints might be in this? Time. The items in the kit. Yeah, what's in the kit? Kids are going to literally think they have to use what's there. They could bring something from home, but not a fully built boat. That's not going to work. Then this is more day one's instruction. I'm going to have the teams brainstorm with each other, standing at a whiteboard space of their own, in teams of 3. Usually I randomly form teams. In my math class, every single day they're working with a different group, so they can work with their friends sometimes or not. That wouldn't work because this would be an extended project, so they would be with their team for the whole thing. So they will be instructed to brainstorm with their team different designs for a fast boat. They can use Google and search for it. They can discuss it however they want to come up with that, then come up with their best boat design and draw it on their whiteboard, outlining what materials they will make. And then that's where this guy comes in. They can take a picture of it and print it on this little thing, prints labels, and stick that in their design notebook. They need to keep all of their definition, constraints, and now they're, excuse me, they're brainstorming and their selection of a design. And I'm going to count their initial drawing as their first prototype and have them share that among the classroom. And then they'll have a chance to iterate on that before they start building if they want. They need to take a picture of each new iteration of their design and continue to fill in their design notebook. Then over the next few days, they would build their notebook, or their boat, which will involve some carving, which can get kind of messy with the foam, so be on a good working relationship with your custodians. That would cover brainstorming, design, prototype, and possibly another iteration after their presentations. Then after they design their boat, back over here, they should have something that works about like this, has a switch on the side that starts the propeller. And I have a big planter that they can race those in. It was too large to bring in today though. You could use an animal trough, whatever you can fill with water. I would suggest doing it outside if possible, and have them race their boats. Then I'm going to add a surprise. These are 1 ounce weights. They're just fishing sinkers. We're going to try them at a couple of different weight levels, and then that's where the math extensions come in. They can chart percent increase, percent decrease. Is it a linear relationship? All sorts of items that go into math with those different tests at different weights. At the end, they'll have to do a discussion on would they go with the same boat design if I allowed them to build a second boat. So that is it. It's just a fun way to come up with the engineering design process, which I was in the FEARS lab this summer, and we saw a lot of that in there. There was a lot of success, but a lot of failures too. And you need to learn how to create another iteration when you have a failure. It's an important thing in life and in engineering. So thank you very much.